Welcome back. Hope you had a good weekend. Last class, we completed with push and pop operations as well as peek operation of stack. I showed you the algorithm as well as the execution of it. And then we did the advantages or applications of stacks. And one of the applications was polish notations. So when we started notation, so what is a notation? Notation is nothing but a way to write an arithmetic expression. So the way you write an arithmetic expression is known as a notation. And then we also discussed or we started the discussion with infix notation. That is, any arithmetic expression can be written in three different ways. One is infix, the other one is prefix, and then that is also called as Polish notation, and postfix, which is reverse Polish notations. So see, infix expression is an expression or a notation where operators are used in between operands. So, for example, a plus b, where plus is the operator and then addition is the operation, and a and b are operands. So, you can find the plus in between a and b. So, it becomes an infix expression or notation. An infix notation is used wherein the operators are used in between operands. And many are the doubt like this is a very simple one with only two operands, but then you can write any number, right? Whatever you do in math is nothing but infix expression. And infix expressions are very easy for humans to read and write. By seeing it, it is easy for us to read and write and solve it. But the same cannot be said to computing devices, because whenever you evaluate an expression, the thing like precedence and associativity are the two important factors which needs to be considered when you are solving an expression, right? We will discuss what is precedence and what is associativity. So it is easy for us to, as a human on paper, it is easy for us to solve an infix expression, but it becomes a very tedious and a difficult job if we have to do it on computing devices. So, and an algorithm to process an infix notation is also very difficult, complex in terms of both time and space consumption. So, in order to overcome that, an expression can be written in three different ways. The other two forms are prefix and postfix. But then, whenever you are converting any expression to any other form, you have to keep in mind that you cannot change the essence or the output of the expression. If I solve the expression in whatever form, the output or the result should be same. There should be no difference in that, right? So instead of writing or solving or evaluating an infix expression, it is either converted into a prefix form, that is the Polish notation, or postfix form, that is reverse Polish notation, and it is easier to evaluate this on computing devices. So what we'll do is, how do we convert an infix expression to prefix to postfix, and then how do I evaluate a expression in stack, as well as how do I convert a infix to a postfix expression using stack, we will do. And then before that, let me go in detail what is precedence and what is associativity, because whenever we are solving, it is whether it's a prefix, a postfix, or an infix, it is always, whenever I am converting it, it is important. Fine. So the notation style, which is known as reverse Polish notation, in this the operator is postfix to the operands, whereas in prefix it is prefixed or before the operands, which is also known as Polish notation. You can see the example here. The infix expression is a plus b, wherein the operator plus is in between the operands, and in prefix it is prefixed to the operands, that is plus ab. The same equivalent prefix expression for the infix expression a plus b. The same way, the equivalent postfix expression, which is also called as reversed Polish notation, is a plus ab plus, wherein it is postfix to the operand. So, whatever is the value of A and B, if I put the same value for all the three, the result should not change. Before that, we'll discuss little about parsing expressions. So, as we discussed, it is very difficult. It is not very efficient, or I can say very difficult to design an algorithm because it is more complex or program. Whether I declare and design an algorithm and then a program, or write a program directly to parse infix notations, it is more complex. So first what we do is, these infix notations are first converted into either postfix or prefix notations and then computed. That is, since the algorithm, to develop an algorithm or design an algorithm or a program to parse infix notations, it takes more complex, like in the terms of space and time. So first what we do is, this is first the infix expressions or notations are first converted into either postfix or prefix notations and then computed. Before that, to parse any arithmetic expression, we need to take care of what? Operator precedence. First thing is what you need to take care of? Operator precedence. The second one is associativity. So these are the two things which we need to take into account, that is operator precedence and associativity, to parse any arithmetic expression. So we'll start with precedence. What do you mean by precedence? Precedence is nothing but when an operand is in between two different operators, which operator will take the operand first is decided by the precedence of an operator. I repeat, when an operand are A, B, C, D, X, Y, Z, whatever, when an operand is in between two different operators, arithmetic operators are addition, subtraction, multiplication, division, modulus, exponent. All these are some of the, like you have exponent also. So all these are some of the exponentation, multiplication, division, addition, subtraction and modulus. Fine. So we'll leave the modulus part, we'll only talk about these. So any operand is in between two different operators, which operator will take the operand first is decided by the precedence of an operator. Precedence or nothing but priority. For example, see, I have A plus B into C. So which is the operand which is in between the two operators? Here I can see B is between two operators. One is plus and one is multiplication, that is star. So now which operator, whether the multiplication should happen first or the addition, because which B is used, it is in between two operators, that is plus and star. So what you have to do is, which operator should get the first priority over the operand. Getting it? So what will happen here? It will be, as multiplication operation has precedence over addition, that is multiplication has a higher priority above addition. First multiplication will happen and then the addition. So how it will do is, first it will be A plus B star C will happen. First B star C will happen. The result of that would be added to A. Getting it? Because B is in between two operators here. I repeat, please pay attention. B is between plus and star. So which operator should get B first? It depends on the priority precedence of operators. So multiplication has higher precedence above addition. What will happen first? First B into C will happen. That whatever is the result of B star C would be added to A. Hopefully you're getting it. This is an example of precedence, a table of operator precedence. Let me say, before that, let me also talk about associativity. What is associativity? So associativity describes the rules where operators with same precedence appear in an expression. For example, you have, see, associativity, there are operators which has equal priority. So when you have operators of equal priority appearing in an expression, then which one has to be evaluated first is determined by the associativity of the operators. They can be either left associative or right associative. Getting it? Associativity describes the rules where operators with the same precedence appear in an expression. For example, here I can see you have two operators, one is plus and one is multiplication, and it is clear, there is no ambiguity, that multiplication has a higher precedence than addition. So I will do first multiplication and then addition. But then in an expression I have operators of same precedence, then which has to be evaluated first is taken care, or is which has to be evaluated first will be determined by the associativity of those operators. So what does associativity do? It describes the rules where operators of same precedence appear in an expression. It will tell you, or it will determine which has to be evaluated first. So example, you can say A plus B, instead of multiplication, let me say minus C. So addition and subtraction has the same precedence, like both have the equal value, equal priority, or equal precedence. So now whether I will do A plus B and the result of that minus C, or I will do B minus C, because again B is between two operators, that is addition and subtraction, which has equal precedence or equal priority. So how will I determine whether I will do B minus C first and then the difference of those two is added to A, or the sum of A plus B, from that I am going to subtract C. So how will it be decided? Like what has to be done first? That time is where associativity comes in picture. It will help you to determine which has to be evaluated first when the operators of the same precedence appear in an expression. Both plus and minus are left associative. So whichever comes first from left to right is evaluated first. So if it is left associative, wherever the operators is determined by associativity, okay? But the plus and minus have equal precedence as well as they are left associative. So whichever comes first from left to right would be evaluated first. So which is first here? Plus is first. So A plus B. A plus B would be evaluated first and then minus C, because left to right, both are left to right associative. If I have A minus B plus C, then A minus B would be evaluated first and then plus C. Getting it? Hopefully you have got it. Please pay attention. Precedence and associativity determines the order of evaluation of a expression. So precedence and associativity determines the order of evaluation of an expression. So let me write one small table for you which will give you the arithmetic operator precedence as well as associativity. And if you want to overrule the precedence, anything you put in brackets, the brackets are evaluated or braces are evaluated first in any expression. It has topmost priority. Anything in bracket, that time it will not consider the operator or precedence. That brackets are evaluated first. So please make a note of this. Operator the next is precedence. Next is associativity. Operator is exponentation. What is the symbol? Yeah. Next is this has got the highest precedence. Associativity is right associative. The next one is multiplication. What is the multiplication symbol? It's star. And then division. What is the division symbol? Slash. Okay. So multiplication and division as second highest. The next is left associative. Both are left associative. Next is addition. And subtraction. This has got the least or the lowest precedence. Again, this is also left associative. Getting it? Please make a note of this. That is operator exponentation. This is the operator has got the highest precedence and then it is right associative. Next is multiplication and division has got the second highest and both have multiplication and division has equal precedence. So when you have equal precedence operators, then you have to check for the associativity. It is left associative, that is from left to right in a expression you scan it. Next is addition and subtraction. Addition and subtraction has got the lowest precedence in compared to the above, but then these two has equal precedence if there are only addition and subtraction in your expression. So when those two operators having same precedence is encountered, to evaluate it, which gets the more priority or which has to be evaluated first depends on the associativity. So again, both of them are left associative. Please make a note of this, then we will move further. So you have made a note, hopefully you have made a note. Now we'll solve few examples. So consider the following and infix expressions and convert it into prefix form. Okay, convert the following infix notation to convert the to prefix. You have to convert it into equivalent prefix form. Okay, prefix notation I can say. You can keep a pen and paper. It will be easy. You start doing it. It will be better. You will understand it better. Fine. A plus B. So this is your infix notation. A plus B into C. Okay. This is the infix notation you have and you need to convert it into prefix form. So what should be done here? First is check for the priority. The brackets have the braces or the brackets have the highest priority. So I will do A plus B first. So prefix is the operator should be prefixed to the operands. So it will be plus AB and star C. I will write it as it is. Next step I will convert it. So this is what I have, and after that, see, I have done only for A plus B. Star C I still need to do. So it has to be prefixed. So it will be star plus A, B, C. This is my equivalent prefix notation. Hopefully you have understood how I converted. See, first you need to, depending on the precedence, you need to go on converting the equivalent form. So in the end, like when there are no conversions left, you would arrive at the result. So A plus B star C, since it is enclosed in a bracket, the brackets have to be evaluated first in material of the operator in between. Suppose inside the bracket you have multiple operators, then you need to take care of the precedence and the associativity if you have the operators of the same precedence. Getting it? Now the next one is A plus B minus C. Okay, what should I be doing here? A plus B minus C is my expression. So, since plus and minus have the equal precedence, they are like having equal precedence, then I should take care of the associativity. Both are left associative, so I will do A plus B first and then minus C. So, I will do plus AB minus C. And now I am to do the C part, right? It will be minus plus A, B, C. This is the equivalent prefix notation. Please make a note. The third one, let me say A plus B by, I have X minus Y. So how will I do that? First brackets, the top one and the bottom one. The top one would be plus AB, yes, divided by minus XY. Fine. After that, which am I left? Only division is left, because once I have done for XY, I will not be redoing it. Once you convert it, again you will not redo it. So division should go first and then plus AB minus XY. Yeah. Slash plus AB minus XY is the resultant expression. So you are not going to do it twice. So once I have to, since I have two brackets here, I have done A plus B by X minus Y. So I will do brackets first. So first bracket is plus AB by remains as it is because I have one more bracket down minus XY. So once I have done minus XY, again I will not be doing it. So solution only for division I haven't changed. So it will go again, prefix is before. So divided by plus AB minus XY is the resultant prefix expression for the infix expression A plus B by X minus Y. Please pay attention. The next one, A by B plus, let me give some space, that is A by B plus C by D. So what will be the prefix one? How will you do that? Can you try doing it? What are the operators we have? We have division and addition. Yeah. So division has got a higher priority than addition. So there are no brackets here. So I will only purely do on the this one, what is that? Precedence. And division and has a higher priority than addition. I have to do division. But then how many divisions you have? You have two divisions here. So again it is left associative. I will do with A by B. So it is by AB and plus I will write as it is by CD. Again, I am left with plus here, so it will be plus by AB and by CD, because by CD I have already done. I will not be redoing it again. This is the equivalent in prefix expression. Next, we'll solve another 2 to 3 so that you will know at last like how we are doing it. Fine. Let me say A plus B star C minus D. So how will I do this? First, what has to be evaluated? Can you try doing it? Then I will do it for you, but I want you to try for a minute. So, see, first the brackets I set. So, A plus B star C, that bracket has to be evaluated first. And then again in this bracket also, you have one more bracket over there. Okay, first bracket would be evaluated minus D. I will keep it as it is. So, I will start here. A plus B has to be evaluated first because it is there in the bracket. If there was no bracket, I will do star first. Getting it? So, it will be plus A, B star C minus D. I am writing stepwise. You can write it in one step. That is not a problem. But for people who are not able to understand, I will write it. Now I will say it is star plus A, B, C minus D. It should be now only minus is left. Minus star plus A, B, C, D. Yeah, minus star plus A, B, C, D is the resultant prefix notation for the infix expression A plus B bracket star C, the whole bracket minus D. Please have a look. And now let me I will do another 2. So I want you to pay attention and try to do it on your own so that you will understand it better. Then A exponent B star C minus D. Please do this. I'll wait for 2 minutes and then I will solve it for you. But I want you to do it, at least try doing it. It hardly takes a minute. So, which has the highest priority? Exponent, right? So I will be doing that first. I will say exponent AB star C minus D. And then I will say now I have to do star as well as minus. Which has the higher priority? The next higher priority, that is the second higher priority, is multiplication. So I will do star exponent A, B, C minus D, right? And now I'm left with only minus, which is nothing but now minus star exponent A, B, C, D. This is still, I don't have any more operators, so I will be, this is my final prefix expression for the equivalent infix expression. The seventh one, this one would be our last one, last example. Please note the question and try to solve this. See here, brackets has to be evaluated first and then the exponent. I want you to do it. Hopefully you have done it. We will solve. First I need to do the brackets. This bracket, let me solve. Again I have two brackets in between, so I will do a plus b first. So plus will be here, ab star c, then I have minus, and again d minus c is nothing but, okay, I'll write it now, d minus e so this is nothing but I have done plus AB star C, okay. Then after that, what do I have? Minus, okay. Another minus is for this, D, E, yeah. But this minus DE is done, but this minus is not done. Still, I'm left with multiplication and one minus, so I'm not taking out the bracket. After that, let me do multiplication because minus has a lower precedence than multiplication. So I will say star plus A, B, C minus again minus DE. So okay, I am still left with what? Now I can take out my subtraction, brackets, because I have still left with one minus. So this minus will go here star plus A, B, C minus D, E. Yeah, this is 1. Perfect. This is the one. Then I do have this which I've not done, and x and y let me do. So it will be plus x, y. Still I'm left with exponent. So exponent will be minus star plus A, B, C minus D, E plus x, y. So this is my resultant in prefix expression for the infix expression 7. Please have a look. You have understood that. Then after this we will do postfix conversions for the same examples. Now we will start with the convert the following infix to the infix notation to postfix notation. Okay. So what is postfix? It is also called as reversed Polish notation, wherein the operators are postfixed to the operands. That will come after the operands. In prefix, you have it coming before the operands. Whenever you are doing it, you need to take care of the precedence as well as the associativity. Correct? So let us start with the first one. What is the first one? A plus B into C. Okay. This is the first one. A plus B into C. Since I have a bracket, without bracket I would be doing B into C plus A. But then since there is a bracket, I need to evaluate the bracket first. It will be AB plus star C, because star C I haven't done it. I have to do it. It will be AB plus C star, right? AB plus, sorry, it is not CB here, it is AB. AB plus C star. Once you do it again, second time you are not changing it. Getting it? You have to do it once only. So once I have done with AB plus, I will not be redoing it again. And C star, because I hadn't done star C, so it will be C star. This is the resultant postfix expression for the infix expression. See, we had the same expression. What was the in prefix expression for that? The prefix expression for same was star plus ABC, whereas the corresponding postfix expression is AB plus C star. Getting it? Please make a note. The second one, A plus B minus C. So I have plus and minus, both have the equal precedence, which is the lowest precedence, and then the associativity is from left to right. That is, it is left associative. Both are left associative here. So plus is there before minus. I will do A plus B first and then minus C. So it would be AB plus minus C, which is nothing but AB plus C minus. So this is the corresponding postfix expression for the infix expression too. Write it down, please. The next one, A plus B by X minus Y. So try to do it. I'll give you 1 minute time. Then I will do it for you. So A plus B by X minus Y, brackets have to be done first. So I will say AB plus by X minus Y. So X, Y minus, right? Then I will be doing AB plus X, Y minus Y. Right? This is my corresponding postfix expression. The next one, A by B plus C by D. There are no brackets here, so you have to check for the priority and associativity, and then you need to do it. So division has, both divisions are there, so whichever it is left associative, so I need to do first A by D, A by B, and then C by D, and then the plus. Correct? Please try doing it. It is AB by, I will say plus as it is, CD by. And then I need to still do plus, it is A B by C D by, and then plus. This would be the resultant expression, postfix expression. The next one, so please do this. Sorry, there's one closing bracket over here. Yeah, now that is correct. Please try doing it. What you have to do, first the brackets. So A plus B star C has to be evaluated first, and then I will be doing minus D, right? So in the bracket, what do I have first? Again, A plus B star C. So A plus B, since it is in a bracket, it has to be evaluated first, because if there are no brackets, then first B star C and then plus B I would have done. Since there is a bracket, I will say AB, where is that, plus star C. Still I haven't completed evaluating it, so I will write the bracket. After that I need to do A B plus is there, C star. So this bracket is done, minus D. So I will do A B plus C star D minus, correct, A B plus C star D minus would be my resultant postfix expression. Please go through that. If you have any doubts, you can write me in the chat box. I will try to answer to my best capability. Write down the sixth question. There are no brackets here, so please try to do it on your own. So exponentation has the highest priority. I will start with that. A, B, then star C minus D. Now multiplication and subtraction. Multiplication has a higher priority. So it will be A, B, cap C star minus D. So I am still left with minus. So it will be A, B, C star D minus. So this is my resultant postfix expression for the infix expression. Write down the next question. Please make a note of this and try to do it. I will solve, but I want you to solve this. First, we'll start with the brackets. Yes. So inside the bracket again I have two more brackets. So I will do A, B plus, then this star will remain as it is, C, and this minus also will remain as it is. It will be DE minus, right? After that, what will I do? So still I haven't completed the bracket, so I will not open it. AB plus. Now star and subtraction. Star has got a higher precedence. So I will say C star, then minus DE minus. After this, it will be A B AB plus C star minus I haven't done DE minus minus, right, X Y plus X Y plus. After that, I'm only left with my exponent. So A B A B A B plus C D plus C star DE minus minus X Y plus exponent. So this is my resultant postfix expression for the infix expression in seventh infix expression. So we did few examples for postfix as well as prefix. In prefix, the operator is prefixed to the operands, whereas in postfix, the operators are postfixed, like after the operands. Main thing when you are converting is you have to check for operator precedence and associativity. Associativity is nothing but like when you have the operators of the same precedence, which one to execute first, that is an operand shares or in between two operators, which one has to be executed first. Suppose they both of them have the same precedence, then you need to take the associativity comes into picture. So we went through few expressions like examples of converting also. Precedence and associativity determines the order of evaluation of an expression. So, the order of evaluation of an expression is determined by precedence and associativity. We converted infix expressions to postfix as well as prefix. Hopefully, have understood that. Now, like next class we will be doing how to convert, how exactly an expression gets evaluated in stack. I will write it and show you to you. I'll take one example and show how exactly it happens in stack. After that we'll write an algorithm for that, and then how to convert an infix to an postfix expression in stack. How does it happen? And I will write an example along with an algorithm. So by that time we'll be completing Polish notations and then we'll be starting with another linear data structure, queues. So homework question for today, write list the advantages, list the application of stacks. Next is write a short note on polish. Please make a note of the homework questions. Hopefully you've understood today's class. Stay safe. Take care. See you tomorrow. Bye bye.